show that the resonance frequency for a series RLC circuit is given by F is equals to 1 over 2 pi times LC under square root. Solution. This is the resonance frequency. The first thing that you have to know is that at resonance, Xc is equal to XL. Xc is the capacitance reactance. XL is inductive reactance. So this is the secret. At resonance, capacitance reactance is equals to inductive reactance, and capacitance reactance is expressed as Xc is expressed as 1 over 2 pi Fc, where F is the frequency, then C is the capacitance. And inductive reactance is expressed in terms of frequency and inductor as XL 2 pi FL. So we have said that at resonance, capacitance reactance is equals to inductive reactance. So we just equate. So we can start with this. There's no problem. 2 pi FL is equals to 1 over 2 pi FC. So you have to make F the subject of the formula by multiplying both sides by 2 pi FC to get rid of this denominator. 2 pi FC. So this and this goes, mean with 2 pi FC times 2 pi FL is equals to 1. Hope you understand. And there you have 2 pi squared. This is F squared, the same thing. LC is equals to 1 out there. And this can also be written as 2 pi square LC F squared is equals to 1. To remain with F alone, this side, F squared, we divide both sides by 2 pi in bracket squared LC. So we divide by 2 pi LC divided by 2 pi square LC. And here you have F squared is equals to 1 over 2 pi square LC. So to get or to find the value or an expression for F alone, we find the square root on both sides. Square root. Therefore we have F is equals to 1 under root over 2 pi square under root LC, which is the same as the square root of 1 over 2 pi square under root LC under root. Are we there? And the square root of 1 is 1. Then the square root of 2 pi squared is 2 pi. Then the square root of LC is LC under root. Therefore, F, the resonant frequency F, is given by 1 over 2 pi LC. Resonance frequency. frequency F. So that's frequency.